Alright guys, so today I'm gonna do something about the AP calculus BC Unit 1 review. It's daily video part 3, section 3 I mean. So hopefully you guys have a basic understand of the limit. So today we're going to talk about something that more advanced about limit. Alright, for the first one, use a graph of f of x showing the figure at the right. Let g of x equals to square root 4 plus x squared. Evaluate limits if they exist. Alright, so we know the function. We know the function f of x is shown in the figure of here, and we know gx equals to square root 4 plus x squared. So first we have to figure out limit as x approaches to the from the limit as x approaches to 2 to the from the right hand side of f of x plus 5gx. So for this one, we can based on the limit property, we can rearrange it to the limit as x approaches to 2 from the right hand side of f of x, and plus 5 limit as x approaches to 2 from right hand side of gx. Alright, so let's see the function. Alright, from the right hand side of the from the f of x to 2, so it goes here, which is 1, and plus 5 times x goes to the 2. X goes to the 2 from the right hand side of gx times 5. So we plug 2 to this function, so we got square root 4 plus 4, which is 2 root 2, which is square root 8, which is 2 root 2. So for this one, we got 1 plus 10 root 2. Right, for this one. For part B, so x approaches to the 1 of f of x times g of x. So as the same property, we pull them out. Limit as x approaches to 1, f of x times limit as x approaches to 1 of gx. So we find the one. If the function is continuous, we just find a point f of 1. So it basically goes to -2 for the f of x. So it's -2 times g of x. So limit as x approaches to 1. So for g we got square root 5. So it times together, which is -2 root 5. Right? It's a second one. For the first one, limit as x approaches to 2 from the left hand side of f of x over g of x. So for this one, we got the same property. Limit as x approaches to the approaches to 2 from the left hand side of f of x, and over limit as x approaches to the 2 from the left hand side of g of x. So we check the graph, and 2 from the left hand side is here, which is 1, and we plug 2 to the g, which is 2 root 2, and we rationalize the function. We rationalize the fraction. We got 2 times 2 times root 2 over 2 times 2, which is root 2 over 4. Alright, the last one. Limit as x approaches to the 4 of g squared x. So for this one, we can rewrite the limit into x. Limit as x approaches to 4 g of x and bracket square. So you plug 4 into it. So we got 4 times 16 square root, and then the big square outside. So we got 20 square root square root 20 squared, which is 20. All right. For next one, find the values of k and m so that the function below is continuous for all reals. So when asking us the function is continuous, what we have to think is limit has to be exist. So which means right hand side and left hand side limits are equal to each other, and they are both equal to the fa at a point. So you're basically asking us the boundaries of the function. So we have to do -2. We have to verify the continuity there, and +3, and that's two points we have to verify. So let's plug negative. So you're asking us to make to find the value that k and m, so the function is continuous. So what we have to do is we just make the limit of the left hand side and right hand side equals to each other. So what we got is x squared, limit as x approaches to the -2 from the left hand side, which goes to this function. We got it 4 plus 2k plus 3. All right. And for the function, goes to the right hand side, we got -2 to the right hand side of f of x. We got 2 times -2 minus 3, which is -7. And these two functions should be equal to each other, so the function is continuous at the point at the -2, they're continuous. So 7 plus 2k equals to -7. So 2k equals to the -14, and k is -7. Alright, k, we solved our k. Next we have to find a k and the value of m. So 2x minus 3, so the 3 this time is the boundaries, so limit as x approaches to 3 from the left hand side, which goes to this function, the middle one function, which is 2 times 3 minus 3, which is 3, and limit as x approaches to the 3 from the right hand side, which goes to the last function, 4 minus 2m, and basically there's no x in the function, so we just write it as 4 minus 2m. So 3 should be equal to 4 minus 2m, because at this point m could be the value that make the function at 3 continuous. So -1 equals to -2m, m is a half. Or hopefully this video is just a very quick review for the limit, and it's probably a little bit advanced for the limit, and next time we're going to talk about something more advanced, like intermediate value theory, squeeze theorem, and something others. And at the same time, I'm gonna tell you something about derivative. I hope you guys enjoy the video. See you next time.